Um, well, let's take a look at the actual problem first from here. Okay, so the problem is you have a 3 by 3 square, and you're gonna take 9 numbers from 1 to 20. Let's put this problem here first so we can read it. Okay, so there will be 9 numbers taken from 1 to 20 without repetition and fill them into this 3 by 3 grid. Excuse me, so that the sum on each row, each column, and each diagonal are the same. This particular part here, the sum of each row, column, and diagonal is the same, reminds me of this. This thing is called a magic square. Now, most magic squares start off like this, and what would you see here if you add these up? These add up to 15. All the columns add up to 15. Similarly, all the rows like that add up to 15, and each diagonal also add up to 15. Now, the details of this we will skip for now, but it's always a property of magic squares. Now, the idea here is our biggest number in the normal magic square is 9. Our biggest number is here, 20. So what we can do is we can make our own magic square using this magic square right here. The easiest way to do so is to start off with the 9. So 9, let's just do it like this first. If we take this 9 and put this here in the same square, let's put the biggest possible number there is. We have 20, right? Um, we can do the same thing with other numbers later on, but the idea here is we're adding 11. We can add whatever number we want, and it will still give us the same magic square. Now, for example, since we're always adding 11, so let's take a look at this 4. Add 11 to that, that becomes 15. 2 here becomes 13. And so on and so forth. So let's just fill the rest in. So this is gonna be 14, 16, yeah, 18, 19, 12, and 17. If you check this one by one, you will get a sum of 48. Let's take a look at the diagonal straight away. 15, 16, 17, that's gonna give you 48. 19, 16, and 13 also gives you 48. All the horizontal, all the rows also give 48. All the columns also give 48. Okay, so this is the biggest possible magic square. Now we can do other numbers. So for example, we can switch this over to 10 if we want to, or whatever other numbers. So we can use all the. Now, the key idea here though is that we start from the smallest possible magic square and we get this largest possible magic square. Now the question now is if there are a primes among these 9 numbers at most, and that the largest number is b, find ab. Now let's take a look at a pattern. For any magic square, we always want the range of numbers from 1 to 9. So for example, 1 to 9, and then 2 to 10, and then we can use 3 to 11, and so on. Okay, so this is what we'll use. Instead of going through the magic square, we will do, let me write that down here first. So a magic square will always have a range of from rather a small number. Let's say the small number is n to n plus 8. For example, 1, 9. The smallest number is 1. The biggest number is 1 plus 8, which gives you 9. Similarly here, our smallest number is 12, and our biggest number is 12 plus 8, which is 20. Okay, so in other words, what we want to do here is we can just list our numbers from 1 to 20, like this. 8, 9, 10. I'm gonna write it, continue it here. 11, 12, 13, 14, 15, 16, 17, 18, 19, and finally 20. All right. What we want to see is we're going to start with this string. How many primes do we have? In this case, 1, 2, 3, 4. We have 4 primes. So the first number is 4. And then the largest prime is 7. That's the first number we want to test. So it's kind of like trial and error, but the reasoning here is pretty simple once you see it. Okay. So the next thing we're going to do is we're still going to do trial and error, but we're going to go to 2 this time. So we're going to go all the way to 10. So our primes are still the same, 2, 3, 5, 7. So that's still the same number. And we continue from there. Okay, I'll leave it to you to continue doing that, but I'll do the third one just as an example. So we start from 3 all the way to 11. So what are our primes here? Our primes here are 3, 5, 7, and 11. So what are we going to do? Let's count the number of primes. 1, 2, 3, 4. Our largest prime here is 11. So this is automatically wrong already, and so on. Okay, all you have to do is do this one set at a time until you get to this final set right here. Okay, now if we do this final set right here, okay, now one more thing, I forgot this part. At most, this term here, a prime. So what we want to do is maximize this. Once we start, if we have 3 here, we don't really have to care for that anymore. If we have 5, then we can get rid of that, and so on. Okay. All right, so that's up to you now how to solve it the final way. But from here on, I think that's how that's going to be easy to understand.